All right, so here was problem number 18 from our kinematics practice problems. We had multiple choice and a few problems. And this is number 18 again. So it asks, a child throws a ball with an initial speed of 8 meters per second at an angle of 40 degrees above the horizontal. The ball leaves her hand 1 meter above the ground and experiences negligible air resistance. What is the magnitude of the ball's velocity just before it hits the ground? And at what angle below the horizontal does the ball approach the ground? Okay, so drew a little picture here. We've got a kid. We see that the ball is released 1 meter above the ground, and it goes up and follows this parabolic path and hits the ground. I'm calling this point right here where the ball leaves the hand of the child as 0. This is the origin. That's what I'm calling it. You can pick the ground if you want. It's just changing two measurements. All right. Again, it's personal choice. So I'm calling this 0, or leaves her hand. And when the ball lands, it's going to be at a height of -1. Right. If you had picked the ground to be 0, then y sub o, where the ball would start, would be 1 instead. So if I want to find out how fast it's traveling and at what angle it's traveling when it hits the ground, the first thing I need to know is how long is it in the air for, right? How long is it in flight? Everything I know is related to the y, or most of the information I have is related to the y direction. So to find that time, I'm going to start with y is equal to y sub o plus v sub o y t plus 1/2 g t squared. All right. And when I do that, I plug in my information of y is -1, y sub o is 0, plus 8 sine of 40 times t minus 5 t squared, right? Because 1/2 of g, 1/2 of -10 is -5. So I rearrange this a little bit, use my quadratic solver, find a website, do out the equation, however you'd like to do it. And we find that t is going to be 1.2 seconds. So for the ball to travel from her hand up and then down and hit the ground, it's going to take 1.2 seconds for that to occur. Okay, so real quick, if we look at what the ball is doing when it's traveling, right, it's probably going to be traveling something like this. And we're going to have components, one horizontal and one vertical, right? So if this is v, this would be v sub x, and this would be v sub y. So that's what we're looking for v. So if that's what we're looking to find, we need to know what v sub x and v sub y are. That's the easiest way for us to do that. Now v sub x is pretty simple, right? Because v sub x is going to be constant or the same the whole way through. So v sub ox is going to be equal to v sub x. So in that case, it's v sub o cosine of theta, or 8 cosine of 40. Okay. And we find then that 8 cosine of 40 is equal to 6.13 meters per second. Okay. Now, I've got that. Now I need to find v sub y. V sub y is changing, right? It increases and then as it goes up, and then decreases as it comes down. And we would like to find what is that, or how much is that when it hits the ground. So to do that, I'm going to use v sub f equals v sub oy plus gt. We know v sub oy is going to be 8 sine of 40, right? Because that's where we started at, and then minus 10 times 1.2 seconds. So when it hits the ground in the y direction, it's going to be traveling at a speed of -6.86 meters per second. Okay. So now we have v sub x and we have v sub y, and their sides, right? They're perpendicular sides of a right triangle with a hypotenuse equal to v, which is what we're looking for. So if we take these two pieces right here and we put them into the Pythagorean theorem, that'll allow us to find v itself. And so we have v is equal to the square root then of 6.13 squared plus negative 6.86 squared. And we find then that it has a magnitude of 9.2 meters per second. Okay, so that would be part A. Oh, this would be part A. Now part B wants to know at what angle it'll be traveling. And again, we have these two sides where this is our angle, right? And then this is our adjacent side or our opposite side. So that tells us again that we'll need to use tangent. And to find that angle, it's going to be the inverse tangent. So it'll be the inverse tangent of negative 6.86 divided by 6.13. And that gives you then an angle of negative 48.2 degrees. So there you go. That is problem number 18 from our kinematics practice.